So I've got something I'm relatively happy with, I guess. Here I'm going to save test and then head over here and I have this lessons directory. I'm going to copy T tab into L tab folder and call it O for jump explicit .asm. Copied. I can go look. Oh, the other thing, let's see. I introduced this file that I had made on the side in a previous tutorial. I don't think we actually used this in a previous video. I don't think we actually used it in the tutorial. So you probably don't even have that there. But what I did here, I made a boo-boo. I like to keep these kind of sacred. Here I use the same thing, S, as my snippet. So if I went S tab now, it'll find Scratch, instead of my snippet. So forget that. I don't want that. What I want to do, I'm going to rename my Scratch file. I didn't need to type the whole thing. Just tab 2. Let me just call this extra1 dot ASM, I guess. There, yeah. There. Yeah, that's better. Okay, so if I want to write something to a Scratch file, I have this extra file to write it into there. Okay. So let's see, that's all saved. I can move right along here. We did, oh yeah, one more thing. Let's see. Earlier I talked about zeroing out your registers and such. However, like, let's say for instance, let me cut this out of there. Here I've just zeroed out my A register, and then immediately thereafter I'm writing some stuff into A. Well, then that means this is just wasted ticks, and in the grand scheme of things, it's a tiny program, doesn't make a big deal, but if I'm doing well, to make a long story short, I got a loop going here, maybe here, jump, or whatever. It's looping around, a couple ticks, can be burning up, whatever, 10,000 ticks a second, in your loop or whatever. I notice on your forums, you go ask some questions about assembly, and you'll get some answers, and then about a year later, someone else will chime in. Oh, by the way, you could have saved a few ticks if you'd used a bitwise shift operator there instead, and it's like, and you're like, okay, it's not the answer I was looking for. That's interesting. But it is important to your bean counters, I guess I call them. Like, I don't know if you work for NASA or something, or you're programming for microcontrollers. You have a very limited amount of memory, teeny tiny things, whatever. Surveillance devices, whatever. Then yeah, then it's important to be able to optimize your program. And a lot of your programmers who may be looking for answers, learn more about assembly, are doing so in order to optimize their C programs, C++, whatever, C#, whatever. And you can make bits of your program run in assembly and cut out all the little extraneous parts, so your program can run just a tad faster, and that can be important in many cases. Okay, there. But yeah, just a general kind of rule of thumb. You see many examples where they clear out all the registers. Wasn't 100% necessary. Like I said, it could just easily have gotten by with XOR CX. See, that was the problem one. See, I'm writing into A, I'm writing into B. That's all taken care of. But there was some artifact, in C in this previous video. Artifacts, So all I really needed to do was here I'm subtracting C from itself, resulting in 0. Zeroed out that one problem register. See, so once you've isolated the actual problem, there you can address it verbatim. Whatever. Okay. Hope I haven't wasted too much time digressing again. Thank you. Here, there. Yeah, so that's probably just a good rule of thumb to do it that way. Okay, so this next one, let me see. We did a jump to a specific location, spot in our program. Here, I believe, whatever. And but then let's say, I don't know, I add some other character in there. Let me just and I can compress all this. Like before, just in case it wasn't obvious, I spaced out some of the characters like that. Oops. Not that one. Yeah, there. This one's 2, this one's 2, this one's 3. So the numbers over here would represent the same thing as the amount of bytes that were being used up. But that's not necessary. You don't have to do that. I hope that was apparent. That was just for a visual reference. I can compress the code any way I want. So there. So let's say here I've got a character there, another character here. There I have, and let me make it a different character. This one will be, let's say, 2 and a different color, 5. Okay, there. Let me save that and have a look. There, I got a couple different characters, a couple different colored characters. Okay, and I can now from here, I want to jump over the first character and only print the second one. Okay, JMP. And here now I've compressed this and compressed that. I can't look here to get the number, but I can jump relative to my current location. Yeah. Or here, let's do it this way. Let's do it the easy way for starters, because that one's just a little bit different. Jump. Before I went jump value, whatever, line number to here, but you can also go relative. Okay, so I can get, as you know, this value represents how many bytes have been used in your program up until this point. So we can use that to our advantage. Let me just copy that. Jump from there back 2, so minus 2. Then that should take us back to this point and call this interrupt over and over. Let's try that, shall we? So we have our endless loop, a small loop. It's looping this little bit here and calling the int over and over and over. Right? Okay. So now, as I was cut that. Saying earlier, if I wanted to jump over this, I want to jump to here, right? Okay, so we got to count the number of bytes, which I know is, this one is 2, this one is 3, and then this one is another 2, right? So you would count 2, 3, 4, 5, 6, 7, right? But you also, the command itself, I think, uses up 3 bytes. So what you end up having to do, if I'm not mistaken, is plus 10. if I'm not mistaken. Let's find out if that's correct over here. Yeah, okay. So it jumped over this bit, counting itself. There, let's see. That. There. Jump to here. Yeah. Okay. So let's just save my test file here. And from here, I'm just going to copy T-tab into L tab folder and call it 05. And this is jump, was it relative, right? Jump relative .asm. Okay, there we go. There, that is jump relative.